right, question 14, which I think might be called 13 for the advanced students. Write down the zeros of each polynomial, use a table of values to test its sign, and then sketch it showing the y-intercept. So the zeros are really easy to get. So for this one, there's, oh, sorry, meant to be writing there. The zeros, well, for x plus 2, it's going to be minus 2. For x plus 1, it's going to be minus 1. For x, it's going to be 0. For x minus 1, it's going to be positive 1. And for x take 2, it's going to be positive 2, yeah? So, let's have a look at 14a. We know, once we start to sketch it, let me put this in, y, x. Okay, so we know it's going to have zeros at -2, -1, 0, 1, and 2. The y-intercept, just like we did in quadratics, we let x equals 0. So we get y equals 0 plus 2, 0 plus 1, 0, 0 take 1, 0 take 2. You could put that in your calculator, or you could realise that the number 0 is here, so it's going to come out as y equals 0. So its y-intercept is actually going to be here, which makes sense. We don't know whether it's going to start up here and do that, or whether it's going to start down here and kind of bounce in between them like that. So let's test. This is -2 and this is +2. Let's test a number this way, like -3, and a number here like +3. So our table of values, x, y, you're probably going to sub these in your calculator, so it's going to be nice and quick for you. So I'm going to have x equals -3 and x equals +3. So if we have -3 plus 2, -3 plus 1, -3 take 1, -3 take 2. Oh, I wish I had my calculator here. So we've got y equals -3 plus 2, -3 plus 1, -3, -3 take 1, -3 take 2, which is a neg times a neg times a neg times a neg times a neg. Neg times a neg is a pos, times a neg is neg, times a neg is pos, times a neg, it's going to be negative. Okay, what if we get rid of these minuses? Here we're going to have a pos times a pos times a pos times a pos times a pos, so it's going to be positive. Which means down, but less than -2, I'm going to be kind of down here-ish. Going to bounce back up. And pretend these are rounder. And it's going to end up in the positives. All right, 14b and c are going to be fairly similar, but b has 2 square roots in it, which means we're going to have 2 parabola-looking things in it. So, let's do our axes. Y and x, yeah, I can't draw. Okay, so our roots are going to be x take 3 all squared, so that's +3, x plus 2 all squared, that's -2. And we're going to get it bouncing off here and here and back up. Oh, that looks unfortunate. Or bouncing off here and here and back down. But we don't know which way it's going to go because it's like x squared times x squared. That's x to the 4. We haven't drawn quartics. So first of all, let's find our y-intercept. Let x equals 0. So we've got y equals -0 take 3 squared, 0 plus 2 squared. So I've got -0 take 3 is -3 squared, 9, 0 plus 2 squared, 4. So that's -36. Oh gosh, that's like way down, but I'm going to pretend it's here. Okay. Now that's a pretty strong hint that we're going to bounce down, cut through there and bounce back up and go that way. But let's double check with the table of values. We want something less than this and something more than this. Don't forget this is -2 and this is +3. So x, y. Why don't we do x is -3 and x is +4. Okay, so if we have y equals 0, -3, take 3 squared, -3 plus 2 squared, well that's going to come out as a minus times a positive times a positive because they're both squares. So it's going to be negative. And if we have, and we're going to have exactly the same kind of deal going on with +4. Because this is a minus times a positive times a positive, it's going to be a negative as well. But I wouldn't blame you for chucking those in your calculator. Which means we're starting off in the negative area. We bounce back off there, it goes through here at some time, turns around at some point, and goes back down there somewhere. These do not have to look great. The next one's hard because we have this thing. And I'll show you what to do. It's like a square, but it's kind of really flat. Let me copy. I was going to copy the question, but I can't be bothered now. It's annoyed me. So 14c, we've got y equals 2x squared, x take 2 to the 4, x take 4. Okay, now let's draw our axes. We can see pretty clearly that we're going to have zeros at, well, this one is just a normal 2x squared, so that's going to have a 0, I'll put it in green, at, well, 0. This one is x take 2 to the 4, so it's going to have 0 at +2. And this one is x take 4, so it's going to have a 0 at +4. Now, we covered this a little bit in class today, but we haven't really addressed it in our notes. Whenever you have a quartic, y equals x to the 4, it looks weirdly fat, but it's like a parabola. So it kind of goes down and back up eventually. I'll graph it in GeoGebra and show you. Sorry, musical interlude. Start graphing. So what was I doing? Y equals x to the 4. Oh, yes, sure, you've got new stuff. Y equals x to the 4. Yeah, it's like a parabola, but it's got a really fat bottom. Which means at this x take 2 to the 4, we're going to end up with something that's either got a fat bottom here, or that's got a fat bottom here. I need to draw it with a fat bottom here, and then it goes back up through there and up through there. We don't know what yet, so let's have a look at the value. Oh, we need the y-intercept. Well, this should be fairly simple. Y equals 2 times 0 to the 4. 0 take 2 to the 4. Oh, that's squared, by the way. 0 take 4. It's just going to come out as 0. So it's going to go through there, which we could already see. I'll cover that back up. We need a table of values to tell us whether we're going to start here or up here. Parabola, weird quartic thing, back down. You never draw these amazingly, so it's really hard to tell the difference between a parabola and a quartic, frankly, if you're not drawing them perfectly. So let's do our table of values. We want a number less and a number more, so something less than 0, I suggest -1. And more than 4, I suggest 5, because I know my 5 times tables. So x and y, let's chuck in -1 and 5. So if we have y equals 2 times -1 squared, -1 take 2 to the 4, -1 take 4, well this is a positive times a positive times the negative, so it's going to be negative. Okay, if instead of -1, if we have 5, what do we get? 5 squared, 5 take 2 to the 4, 5 take 4, we've got a positive times a positive, positive times a positive, it's positive. Which means we're going to start down here. It's going to come back around. This one, it's going to just be really flat at the bottom. This one's going to go back up and end up positively. And I actually want to draw that in GeoGebra, see how nice and accurate we were. So, oh, come on. I'm also having to find the equation in the textbook at the same time. So, if I've got y equals 2x squared times x take 2 to the 4 times x take 4. Oh, to the 4. Come on. Times x take 4. Two times -1, 4. -1 take, yeah, that's to the 4, so that's positive. -1 take 4, negative. What have I done wrong? Two x squared, x take 2 to the 4, x take 4. 2x squared, x take 2 to the 4, x take 4. We had a normal parabola thing looking at... Oh, yeah, it's updated now. It just hadn't updated before. So, our basic shape was right, but have a look at this turning point all the way down there. We would have never gotten that. That's fine. We're not expected to yet. Lol.